Blood moon. Why the moon turns red during a lunar eclipse. A blood moon lunar eclipse was not always something to look forward to. When the moon transformed red thousands of years ago, the prehistoric Mayans and Mesopotamians feared that something monstrous and immoral was eating the moon. They would shout at the night sky to try and fend off the voracious beasts. Since the average lunar eclipse lasts around 100 minutes and the moon reverts to normal afterwards, they were perhaps actually convinced that their whooping and howling actually worked. You might have observed that during a total lunar eclipse, our moon appears red. We call this a blood moon. But what makes it turn red? And why not some other color, like blue? Or why doesn't it just stay white like it is the rest of the time? Welcome to Brainbender Solarium. Join us as we travel through space and explore the blood moon and why the moon turns red during a lunar eclipse. Eclipses, particularly total eclipses, are rare events thanks to the intricate dance of orbits, timing, and visibility. Remember the Great American Eclipse fever of 2017 in the US? The US will have to wait until 2024 for the next total eclipse of the sun. If you have the chance to catch any eclipse, be sure to take it. NASA retains a handy list of upcoming solar eclipses that includes the date, time, duration, type of eclipse, and where it will be visible. For instance, the next one on the list is on the 21st of June, visible in Africa, Asia, and Southeast Europe. The same site also hosts a table for lunar eclipses. There's one slated for July the 5th, visible from the Americas, Africa, and Southwest Europe. You may not have to skip an eclipse just because you are in a different geographic area. Observatories around the globe often step up to offer live streams of significant eclipse events. The Virtual Telescope project also contributes to eclipse action when feasible. The moon's orbit around Earth is angled at about 5 degrees compared to Earth's orbit around the sun. This indicates that the moon spends most of its time either above or below Earth's orbit level. And the story of Earth's orbit around the sun is essential because Earth's shadows lie at just the same level. Our natural satellite usually passes above or below Earth's shadows during full moon and misses them completely. No eclipse takes place. But 2 to 4 times each year, the moon goes through some portion of the Earth's penumbral or umbral shadows, and one of 3 types of eclipses happen. When an eclipse of the moon occurs, everybody on the night side of Earth can see it. About 35% of all eclipses are of the penumbral form, which is very difficult to identify even with a telescope. Another 30% are partial eclipses, which are simple to see with the unaided eye. The final 35% or so are total eclipses, and these are quite exceptional events to behold. Before looking at the blood moon, let's look at why the moon appears white in the first place. When white light from the sun shines on the moon, its surface reflects all the light, and thus the moon looks white. But when a lunar eclipse occurs, the Earth blocks some or all of the sun's direct light from reaching the moon. This cosmic event only occurs during a full moon, which occurs once every 29.5 days, or the length of one complete orbit of the moon around the Earth. So why don't we have an eclipse every month? The moon's orbit is tilted a few degrees in relation to the Earth, so the Earth, moon, and sun don't always line up. When the Earth does eclipse the sun, it casts 2 types of shadows on the moon, a larger shadow known as the penumbra, and a smaller, darker shadow recognized as the umbra. But wait for a second. Whenever you look up at a full moon, you're seeing sunlight that's reflected off the lunar surface. If something were to block that sunlight, like the Earth, then, in theory, the moon should disappear from sight. But during a total lunar eclipse, when the moon passes through the Earth's shadow, we get a red moon, not a vanishing one. So, what's going on? To figure it out, let's take a swift trip to the lunar surface. According to NASA's simulation of what the Earth looks like during a total lunar eclipse, there is a red ring around our planet. Everywhere you see that ring is either a sunrise or a sunset. While it's true that no direct sunlight reaches the lunar surface at this moment, Earth's atmosphere bends the red wavelengths of light. So that redness you see during a blood moon eclipse is a blend of light from every sunrise and sunset on Earth, all occurring at once. So the moon looks red for the same reason that sunrises and sunsets on Earth are red, because of a phenomenon known as Rayleigh Scattering. Named after the British physicist John William Strutt, also recognized as Lord Rayleigh, who discovered it in the late 19th century. It describes how different colors of sunlight interact with the Earth's atmosphere. Look at the sky during the daytime, for instance. It appears blue because air molecules in the Earth's atmosphere scatter blue light more efficiently than red. But during sunrise and sunset, the light travels through more of the Earth's atmosphere before reaching your eye, which has two effects. First, it means more overall sunlight is dispersed, making the sun appear dimmer. That's why you can easily gaze upon the sun at sunset compared to at high noon. And secondly, more scattering means more blue light is scattered away, leaving the redder wavelengths behind. Similarly, the ring around the Earth during a total lunar eclipse is red because the sunlight travels through a long stretch of the Earth's atmosphere, from one end of the planet to the other. The blood moon is really nothing more than the refraction of light. Rather than fearing a blood moon as the ancient Mayans and Mesopotamians did, why not think of it as a romantic moment? After all, it's the only time when you can see both the sunrise and sunset concurrently. Thanks for joining us. We hope you found this video interesting. If so, take a look at some of our other videos you see on the screen now. Also, ring that bell to keep up with new content that we publish weekly. We'll see you next time, here on Solarium.